Hi, I'm Kaustubh, and today we are going to learn about breadth-first search and how to implement it using a pseudocode. Now, to first understand breadth-first search, let us define our problem and why we need breadth-first search. Suppose we are given a graph, which has A, B, C, D, E, and F nodes, and we want to traverse this graph in such a fashion, beginning from A, that we first visit all the children of A, that is B and C. Then we want to visit the grandchildren of A, D and E, and then followed by the great grandchildren of A, and so on and so forth. Now, to traverse the graph in such a fashion, we need an algorithm, and that is called breadth-first search. To understand breadth-first search, let us look at the pseudocode and use it to find the traversal of this graph from the initial node A. Now, in this pseudocode, you can see we are using two data structures. One is a queue, and another is a data structure which keeps track of whether we have visited a node or not. So, we have an array which contains all the nodes, and the values in this array denote whether we have visited that node or not. So 0 denotes we haven't visited and 1 denotes that we have visited. And then we have a queue. Now let's start executing our pseudocode step by step to understand and find out how to find the traversal of this graph from the initial node A. Now we create a new queue, then we enqueue this queue with the initial node. So our initial node here is A, so we'll enqueue it with A. Then, while queue is not empty, we'll execute this. Queue, as we can see, has A in it, so it is not empty. We'll dequeue the queue and get the topmost element of queue. So that is A. So we'll dequeue the queue. Now, we'll check if A has been visited or not. So A has not been visited. So we'll mark A as visited. And then, for every node that is connected to A, we'll check if they have been visited or not. So A is connected to B and C. B and C both are not visited. So we'll enqueue both of them in our queue. So we'll enqueue B and C in the queue. Now we are done with this iteration of the loop. So again we go to the top of the loop. Again we check if queue is empty or not. So we have B and C in our queue now. B and C. So our queue is not empty. So we'll dequeue the queue. Now we dequeue the queue. Now we have B with us. We'll check if B has been visited or not. Now we can see here B has not been visited. So we'll mark B as visited and then check for all the nodes connected to B. As we can see here, B is connected to A and C. Now A and C, A is visited, C is not. So according to this part of the pseudocode, we will only enqueue C. So we enqueue C. Now we are done with this. And again we go to the start of the while loop. Again we check if queue is empty or not. We see our queue has C and C in it, so it's not empty. Now we dequeue the top of the queue. So we have C with us. Now we'll check if C has been visited or not. C is not visited, so we'll mark C as visited. Then we'll check all the nodes connected to C if they are visited or not. Now C is connected to A, B, E and D. Now out of these 4 nodes, we can see A and B are already visited. So we won't enqueue them. We will only enqueue D and E. So we enqueue D and E. Now we are done with this part of the code. So again we go to the while loop. We again check if queue is empty or not. As we have C, D, E in the queue, queue is not empty. So again we dequeue the queue. Now we have C with us. Now C will check if it has been visited or not. But here comes the catch. We visited C in the last iteration. So C is already visited. We don't need to enter this part of the code. We'll just get out of the code, again get to the while loop. Now we have D and E in the queue. We'll dequeue, so we have D with us. Now we'll check if D has been visited or not. We know that D has been not visited by looking at the visited array. We know D is not visited, so we'll mark it as visited. And then for all the nodes connected to D, we'll check if they are visited or not. But D has only C in it, C connected to it. Now we can see that C is already visited, so we don't enqueue anything. We are done with this part of the code, so we'll get out. Again, we'll come to while and check if queue is empty or not. As we can see, our queue has E in it, so we'll get E. We'll check if E has been visited or not. E is not visited, so we'll mark E as 1. And then we'll check for all the nodes connected to E. As we can see, E is connected to C and F. Okay, so C out of those 2 is already visited. So we won't enqueue it. But F, as we can see here, is not visited. So we'll enqueue F. We are done with this part of the code now. So again, we'll come to the top of the loop. Now we'll check if Q is empty or not. Q now has F in it. So we'll dequeue the Q. We'll check if F has been visited or not. As we can see here, F has not been visited. So we'll mark it as visited. And then we'll check for all the nodes connected to F. Now F is connected to E. E, as we can see, has already been visited. So we don't need to enqueue anything. So we get out of this part of the code. Again we go to the top of the loop. Now we get to see that our queue is empty as we have dequeued everything from the queue. Now we are done with our traversal and we exit the loop. Now the thing to check here is how do we know we have done breadth first search or breadth first traversal of this tree starting from A. We look at the dequeuing order. So as we can see here, we dequeued A first. So we can see we dequeued the root first. Then we dequeued B and C. B and C are the children of the root, so we can confirm that we have dequeued B and C. Then we dequeued D and E. As we can see, D and E are the grandchildren of the root, so we have dequeued D and E. Then we dequeued F. Then we can see we have dequeued F, the great grandchild of root. So this is how we can confirm that we have maintained our order. Now the ordering BC or CB doesn't matter in this case. Again, DE and ED doesn't matter in this case. That's why we can confirm that this ordering is correct. And also, this breadth first search algorithm can be implemented on any type of graph. Like even if you have a directed graph, it will work. I hope you enjoyed the video and understood the concept. Thank you for watching the video. Have a great day.